Hello there and welcome to a brand new lesson. This is Happy Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at an introduction to functions. In our previous lessons, we looked at all relating to relations, and this time around, we want to look at the relations that are actually functions. These are our lesson objectives, and without much ado, let's quickly look into them. So let's start by looking at what a function is. When we say a function is a special type of relation in which each element of the domain is related to, take note, exactly one element of the range. It says a special type of relation in which each element in the domain is related to exactly one. So every element in the domain is related to exactly one of the range. Under relation, we looked at the following. So we saw all these to be types of relations, but are they all functions? That is the question we should ask ourselves. So considering the first one, this very first one was a one-to-one relation. If we take each element in this relation, does it map to exactly one? If it does, then we can consider it as a function. So when we take one-to-one, this element here is mapped to exactly one. This is also mapped to exactly one, and this is also mapped to exactly one. Hence, we can say this has got the green light, and then it is a function. On the other hand, when we look at this, 4 is mapped to two elements and not exactly one. That alone should tell you that what this doesn't satisfy the condition for a relation to be a function. If you look at this, on the other hand, we have one element being mapped to just one. This one element is also mapped to just one. This one element is also mapped to just one. This one element is also mapped to just one. Even though when we look at the range, two elements are being mapped to the other, that is not the basis of justifying whether a relation is a function or not. But then we justify it by looking at the domain. So if the domain is actually one pointing to one, you see, each one pointing to one, then it is a function. With that justification method, we can say this is also a function. So we'll give it a pass and then label it with what? A green. Now for this last one here, we realize that there is an element that is mapped to more than one. So since it is mapped to more than one, it is also not going to be a function. You see? So on that note, I'm going to clear off these that are not, and then we focus on this. Now this we have over here on the left hand side is a one-to-one relation, and this on the other hand is a many-to-one. Many-to-one. So we say a function is a one-to-one relation or a many-to-one relation. So with all that we've done, we have cemented the fact that what a function is either a one-to-one relation or a many-to-one relation. So if it is one-to-one, yes. If it is many-to-one, yes. But for one-to-many, it is a no. Because you realize that one input is trying to give us more than one output. For many-to-many, it is also a no. Because you have many inputs having what? Multiple destinations. So that is the difference between a function and a relation in general. So all functions are actually relations, but not all relations that are functions. So for our next session, let's look at what the domain and the range is. When we talk of domain, yes, we have mentioned this before in our previous lessons, but this time around, let's be more specific. So when we talk of domain, that is the set of all possible input values. If we take this examples we had here, the 2 is in the domain 3, -2 and 10. All these are in the domain. Then the range is the set of all actual output values. So sometimes you might have more elements here. Let me put 7 here, which are all in the codomain, but do not have arrows pointing to them from the domain. Hence, they are not part of the range. So we say the range are only the set of all actual output values that are in the codomain. So this is an output value. This is also an output value. And then the 9 is an output value because they are outputs of the X values or the domain values or the input values. 7, on the other hand, as I've written here, has no input. Hence, it is not part of the range, though it might be part of the codomain in general. The last thing we want to look at under this section is the function notation. In most lessons that we have covered so far, we would see functions written as y equals, then we have our 2x plus 1. But mathematicians often do not want to write it this way. We rather use f and then into bracket x. Now we read this as f of x. So a function in terms of x. You see, so you can say f of x is just being the y. Hence, we can write, instead of y equals 2x plus 1, we can write f of x equals 2x plus 1. Most often, apart from f of x, you can also see a g of x. So 2x plus 1. That is, if a function has already been used as the f, and you want to state another function, then you say g of x. If there's another third function, then you can use your h of x. So we say h of x being another function, let's say x plus 5. So in that order, if f has not been used, you can use your f, then followed by g, and then h. These are all functional notation. So f of x, g of x, and then h of x. Now it simply means that the rule named f uses x as an input. So the inputs are always what you have in here. The input can be any variable, but then as a standard, most of the times we use the x values or the x variable. So this would basically be all for what functions are, the range, and then the domain, and then also our functional notations. So we'll end this lesson here, and in our subsequent lesson, we'll look at the mapping diagrams and then function rules. If this is your first time on this channel and you think it will be of help, you can always choose to subscribe if you so do, so that anytime I release a video, you'll be notified as well. Just have Beyond Numbers where we learn maths the easy way. Bye for now, and do stay safe.